So we're recording now. So 10 o'clock. Let's start this thing. Welcome back, or welcome for the first time to Unhindered by Coding. Um, this is a sabbatical year just started a couple of weeks ago for me, and I'm going to try to do a lot more programming than I normally do. And I decided that I was going to, as part of that, actually program live on the internet. And see how that goes. And so this is episode 5. Um, starting out by working through the Rustlings exercises. One of my goals this year is to learn Rust well enough to decide if I care. I think I do. I think that there's a lot going on in Rust that's important, and that it has a lot of significance. But I also didn't feel like I understood it well enough to know like how I felt about it. And so we'll see how this goes. But I hope that, I think it's going well so far. We're working through the rustling exercises, which are actually a really nice set of introductory Rust exercises. Some of the best, actually, that I've run across. There's a lot of languages have sort of a set of exercises to help you learn the language. But I found that some of them get really into the weeds in ways that aren't super helpful later on. Like they don't really map to real world usage patterns very well. And others are overly simplistic. And I think that the rustling exercises have done a pretty good job of capturing important elements of Rust in a way that's useful. I think the quizzes, I totally am not sold on the quizzes so far. I think that they don't really act as quizzes in a useful way. They're really kind of just more like another exercise without hints. And I guess if I had ideas and time, maybe I could suggest some things to the Rustlings people. I don't know. I'm not sure what that would look like. I'm not going to worry about it for now. So we are getting near-ish the end. I think we're about 80% through the exercises. And I don't think we'll finish today, but we might be pretty close. So I'll have to be prepared for where we go next when this continues. Well, I'm streaming Tuesdays and Saturdays, 10 a.m. to noon, my time, which is Central Time in the United States. And that's a little early in the morning for a lot of people in the U.S. Might have to think about the timing too, but for now we're going to stick with this. Yeah. So, and I should say there is the possibility that I'll be a little fidgety. I dislocated my knee a week and a half ago, and I'm wearing a knee immobilizer brace thing, and it makes sitting here for 2 hours a little awkward. And I don't know. We'll see how that goes. It went okay on Tuesday, but it isn't the most comfortable setup in the world. So sorry about that. But let's actually get into it and do some Rust. So we had left off last time. Actually, if I go to so we've done about 80% of the exercises, 67 out of 84. We had left off here. We had done box and arc and the first 3 iterators exercises. So we got 2 more iterators exercises. There's an exercise on threads. There are 4 exercises on macros, and I don't know squat really about macros in Rust. So I may really flail when we get to that section. I don't know. Quiz, and then clearly some randomy things that they kind of tacked on at the end. So I don't know. Maybe we'll get to quiz 4. We'll see. and see how things work out. Okay, so we've got 2 more iterators exercises to go, and let's see where we get there. So we're supposed to complete this factorial function to return the factorial of the given number. They don't want us to use return. They don't want us to use looping or additional variables. For an extra challenge, don't use recursion. Okay. Oh, this is in the iterators. So I bet that they want us to generate an iterator over the numbers from 1 to num. And then there's a product, I think, on iterators that you can call, and that'll compute the product of the values in that iterator. So I think that actually is probably the thing to do. Because otherwise, I mean, if you don't have loops and you don't have recursion, how do you do this, right? This fundamentally requires some kind of looping or recursion. You've got to iterate across, right? You have to iterate across some collection of values. And I guess that's the hint, is that we use an iterator in functional languages. It'd be a bit like using a higher order function to do the repetition part for you, and you just say what it is you want to have happen. And if product didn't exist, we could probably use something like fold or reduce. I think one of those exists, to do the multiplication part. It might actually look into that, because that would be worth sort of understanding. But let's do it first with an iterator. So I think we can say 1 ... equal num. I think that's a thing. Dot product. Is it going to be that easy? I don't know. Hit save, see what happens. Oh, bonus prize. That's what I get for looking at the documentation for iterators last week when we were doing this, because I remember seeing the product thing. So you need the equals. Actually, if we do the not equals, it will be less than on the right-hand side instead of less than or equal to. So we end up missing the last value. So in the test here, factorial of 4, instead of getting 24, we get 6, because we do 1 times 2 times 3, but we don't get 4. So that we need the equals here to say we want equality on the right-hand side instead of less than. And then the rest of it just works. I am curious, actually, now, wrong thing. Get out of that. Rust iterator. So this has got all these things, and this is where product was somewhere, right? Yeah, product was right here. And there is going to be some kind of reduce right there. So I don't think I've ever used reduce in Rust, and so I'm curious to actually try this. I mean, product would be clearly the thing to do given that it exists, but reduction, we take a closure, sort of an anonymous function, a lambda, that takes 2 arguments, the sort of result so far and the next item from the iterator, and then the body is the combination of the 2 that we want to iterate over. So we could, as an alternative, say reduce, boom, what did they call it? Just a cumin item. So those are good names. And in this case, we want to multiply the product so for, and actually that suggests that those names aren't great. So we could say prod and value, and this is the product, and this is the value, And so we want to return that. And I think that will then also pass. No. Why? Oh, I bet a reduce, returns. Oh, it returns an option. Well, that's interesting. So reduced returns an option, presumably BPI does. It says right here. Oh, if the iterator is empty, return none. Oh, interesting. So, and fold would be the one that would take another argument, which is the starting value, and then fold probably doesn't return an option. Yeah, it just returns a value. So here they have sum defined as a fold. So I think if we use fold instead of reduce and then start with a 1, fold 1, not that. Now that I think will kind of work. Yeah, actually, to have product in standard is a little weird. I was surprised by it too, because things like product and sum only make sense over iterators of numbers. But there aren't that many things that only make sense over iterators of numbers, and maybe they felt like creating a separate namespace for just that handful of things wasn't worth the trouble. But that's total speculation. I haven't looked it up. But I was certainly surprised that that's where that ended up. I wouldn't have guessed that that was where that would have been. So that worked. And then we could have stuck with the reduce and either just unwrap, which in this case will work because we never call it with anything less than 1. I feel like that would that fail if we added a test for the factorial of 0? Test fn factorial of 0, assert eqbang 0 factorial, sorry, factorial of 0 is 1. So I think that's going to fail. Oh, it didn't. Really? Oh, because I put 1 here. That's why it didn't fail. Because now this is going to be an empty range, and so calling reduce on that, it returns the option none, and we don't handle the none value. So we try to unwrap a none here, and that goes boof. Whereas if we went back to fold, and then we don't need the unwrap, that will work. No, what did I do wrong? Oh, because the starting value is 1. We're computing the product, not the sum. Okay. So that would work. Yeah. So really, that's probably more the right answer in this sense, because that will handle 0. It won't handle negative values, but it's not obvious what to do there. Like, what is there is math about the factorial of negative values using the gamma function, and that is way beyond our pay grade here. And certainly not what they mean for us to be exploring at the moment. So we could have something that returns an error. So we could change factorial to return a result type instead of a U64, so that there could be an error if the the input num was less than 0. But we're definitely not going to worry about that now. So I think this is pretty good. Questions? Doodly-doo. And on to iterators 5. So let's define a simple model to track Rustlings exercise progress. Okay. Progress will be modeled using a hash map. I don't think we have done anything with hash maps yet in these exercises, and I don't know that I've written much code with Rust hash maps, if any. So I may flail around in the syntax a little bit. The name of the exercise is the key, and the progress is the value. 2 counting functions were created to count the number of exercises with a given progress. These counting functions use imperative style for loops. Recreate this using iterators. Only the 2 iterator methods, count iterator and count collection iterator, need to be modified. Okay. And so they have these 2 statuses for exercises, an exercise is done or pending. And so I think when they talk about progress, that's what they're talking about. And here they call it, oh, actually interesting. They have none, some, and complete. So presumably no progress is you haven't even started the exercise. Complete is it's done. Some would be like this exercise where we opened it, and I mean, technically we haven't really done any work on it other than talk about it, which the computer doesn't know anything about. Yeah, this will be our progress, and we have 2 working, well, we have 1 working iterator. We have parts of this done. Okay, hang on. Let me make sure. 2 counting functions were created to count the number of exercises. These use imperative style for loops. Recreate this using iterators. Okay, are we? So we've got a count 4 that works, and we want to create a count iterator that does the same thing but uses iterators instead of loops. And we have a count collection that works, but we want a count collection iterator that does the same thing but with iterators. And we have tests that presumably fail because these things aren't right. Okay, so let's look at count 4. So we've got our hash map and a progress argument, and we're going to look for the number of elements that have that value. So we set the count variable to 0, and it's got to be mutable because we're going to update it. And then for val in map values, so map.values gives us an iterator over the values in the map. There's going to be a map.keys that will also give us an iterator over the keys, which is not relevant here. And if, so this for loop goes over those, and if the value matches the one that we want, it was sent in, then we'll increment the count and we'll return the count. So I think this is, if we just do a filter and a count size length thing on the iterator, I'm not sure what the right word is. This should be pretty straightforward. Let's actually start by returning 0 so that both these actually compile, and that we're just getting failing tests, because I'm assuming that they're going to be tests that fail. Yeah. So count complete was expecting 3 and got 0. Count collection equals expected 6, etc. So there's a get map function that they probably define. Okay, yeah. So down here, they define a map and insert values into it, and they're like get count complete takes that map, says how many iterators do we have, or how many complete exercises do we have. Okay, so let's see if we can actually do something better than returning 0. So we know that map.values is going to give us all the values, and if we filter on that, and that's going to take a predicate, which is a closure V, and we want to say if, we'll say val to match val equal value, and we have the ampersand value here because we don't want to take ownership, I think, is the problem. If we don't have the ampersand, then I think our closure here will take ownership of value. Well, maybe that's okay here. I think up here it's a problem because we would take ownership on this line, and then the next time through the loop, we would try to take ownership and bad things would happen because it already was owned by somebody. But here, because it's in this closure, maybe it'll be okay. Let's not worry about that quite yet, and we'll see where we go. So we'll filter, and then I don't know what the count. Oh, yeah, count maybe. Is that going to work? No implementation ampersand progress. Well, that's interesting. So I wonder if we do need to just get rid of that. No. Oh, bad idea. That made it worse. Oh, because value is a reference. So this is, okay, let's go back. Let's look at the documentation for filter. Make sure we understand what's going on with the types. Filter. So, so the predicate is going to take a reference to an item and return a Boolean. So that's why it has an ampersand, and that's to make sure that our predicate doesn't take ownership of the values, because we don't want that to happen. Okay. So because the closure past the filter takes a reference, oh, so sometimes you have a double reference. And then you need to undo the reference to get the equality or the check to happen. So I wonder if that's, oh, I wonder if we could use the ampersand in the argument. Well, actually, I don't know. What if we do that? Is that going to be a thing? Oh, that worked. Okay. And now more of our tests passed. So 2 of our tests passed and 2 failed. So this did cause the count iterator test to pass. Woohoo, that's exciting. Good evening, Ugatha. It's always so weird. How do you pronounce people's names when their names are like apparently random collections of characters? But good evening. And by saying good evening, I assume you're probably in Europe because it's 10:30 in the morning here. So that would make, I'd say it would make more afternoon. So maybe actually you're in Asia somewhere if it's evening. So that worked. And just for fun, we could presumably have done the star thing instead. Yes, so that also works. But I like that pattern matching here. I think that was kind of nice. Okay, cool. So it's 5:30 there, so that probably means continental Europe, right? 7 hours would be, yeah. So continental Europe, someplace. So cool. Welcome. So that works. I think that takes care of that one. and then we'll have something similar here. So what was the different count for? Count so what is this count collection for? So it maps over, it maps over the whole collection instead of mapping over just the values. And then, no, it's got a vector of hash maps. Oh, so the collection here is a vector of hash maps, and we're counting how many across all the collections in that vector have the desired value. So in this case, we have nested loops. We first map over the vector, and then for the map that is in that vector, we map over the values. And so this part actually is exactly the same. Move you down. This is exactly the same as this for loop up here. Yes, it is. So they actually could have called count for in this to replace this inner loop, which would avoid some duplication. Probably would have been a good idea, but it isn't really the reason that they've got us here. So collection is a slice of hash maps. So actually when I was saying it's a vector, that's wrong. It's not a vector, it's a slice. So it's a pointer to basically a part of an array of hash maps. And so we're going to have to iterate over collection. And then for each map, so that iterator over collection is going to give us an iterator of maps. And so we want to turn that map into a list of its values. And it would be nice to combine them all into a single iterator, which smells like flatten or something in that neighborhood to me, or maybe flat map. Works like map, but flattens nested structures. So yeah, so here we iterate over a slice of words, and then we call s.chars, which gives us a collection in the same way that calling .values is going to give us a collection. And flat map then joins all those together into one big thing. And now we can filter and count like before. So I think flat map is a good choice. I shouldn't say not choice, because there's probably a lot of other ways to do it. And obviously, if anybody's got suggestions or things you'd like to see us just try, feel free to share. But I think flat map sounds like a deal here. So let's do that. Flat map underscore, yeah, map, and it's going to take a map, and we're going to return map dot values, and that's going to give us an iterator over all of the values. And at this point, we now do the filter. So it really, from here on, it's the same as up above. So we'll filter, and we're going to have to go to multiple lines here because this is really getting long. Val equal value dot count. So I think that's gonna work. Yeah, well done. Okay, so let's oops. So we take the slice of hash maps and make an iterator out of it. So that's an iterator where every value in the iterator is going to be a map. Flat map is going to take each map and turn it into a collection of values. The flat part is going to, so once we've gotten the values, we essentially have a collection of collections of values. So we've got nesting going on. The flat part undoes that nesting and turns the collection of values into one long collection of values. And then we can filter the values that we're after, namely the ones that match the passed in value, and count. So yeah, cool. Does that make sense? Questions about that? In particular, like, is this part, like, we good with that? Because that's a little weird if you're not used to it. Going? Awesome. That, I think, is a fine solution, and I am happy with that. And that finishes iterators, and so we're going to head off to threads. Threads. There's only one thread exercise. I find this a little odd because threads are pretty complicated, and I don't know if the Rustlings people felt that threads were esoteric enough that they didn't want to spend a great deal of time on threads. They wanted to have one exercise just to sort of show that that's a possibility, but they didn't want to go any deeper than that, or exactly what's going on here, because threads are complicated. I feel like there's potential for certainly more than just one exercise. But okay, so the idea is the thread spawned on line 22 is completing jobs while the main thread is monitoring progress until 10 jobs are complete. Because of the difference between the spawn thread sleep time and the waiting thread's sleep time, you see 6 lines of waiting and the program ends without timing out when running. You've got it. What? That didn't make sense to me. Okay, let me look at the code and we'll come back to the note. So, status, so we've got a job status struct which wraps a U32, which is how many jobs are completed. So we've got an unsigned int, how many jobs are completed. And we're going to have initially that 0. Now we want to share that across all of the threads, I suspect, because each thread wants to be able to increment it when they complete their job. And if we're going to share something like this across multiple threads, then we need to wrap it in an arc, which ensures that it is that there's appropriate memory management happens. So the ARC stands for asynchronous reference counting. So we're going to have to make sure that we know how many people have a pointer basically to this job status. And when that drops to 0, then we can free that up. And arcs can be cloned. And so we'll pass in a cloned shared status to each thread. And it feels like this is not being done correct. Oh, there's only, oh no, there's a loop. Oh, that's in the loop. Okay. That's weird. So there's only one thread. I was somehow thinking there was going to be a bunch of threads. So the thread is going to get a shareable copy of that reference. So you clone the arc. That doesn't actually clone the job status. It just clones the pointer to the job status, so that everybody will be pointing to the same count, but it'll be controlled through this arc. And that way the thread can update it, and the the main thread can read it. Now, interestingly, so one thing they don't do here, and I don't think they do this in any of the exercises, and this I think is part of where the whole threading thing gets complicated, and maybe it would make sense to have more exercises on this if they decided they cared. This doesn't handle potential race conditions by adding a mutex, mutual exclusion, which would be the kind of normal thing you would see with a shared struct across threads. It turns out to not matter here because this uses the single writer principle. So only one thread ever writes to the shared variable. And in general, if you have the single writer principle, you don't have to worry about race conditions. And only this thread ever writes to this shared variable, does it right here. The main thread never writes to it, at least not after the threads have started. You could argue it sort of wrote to it when it created it, but there was no threading at that point. It reads from it, but it doesn't ever write to it. And so I think that's why they don't need mutexes here, is they're using the single writer principle, which is cool. But again, that's kind of subtle, right? If you don't know anything about threads and mutexes, problem is, are you going to learn that in some exercises like this? And I don't know. It's like, what are the assumptions being made here in Rustlings? Are you assuming like fairly experienced programmer just trying to learn Rust? In which case, it would maybe make sense to do more here. But if you're also assuming, or if instead you're assuming a more introductory person learning Rust, getting into this would probably be very weedy and not helpful. So, but we'll not worry about it for the moment. Okay. And the idea is that we will loop here in the thread. So for 10 times, we will sleep for 250 milliseconds. Then we'll increment the number of completed jobs, and then we'll come back. And so that's what this thread does. And here, this does a spin wait, which is kind of gross, but they also are probably trying to keep this reasonably simple. They check to see if we've still got less than 10 jobs waiting, and we print waiting, and then we sleep. And we sleep for 500 milliseconds. So 500 milliseconds should be enough for roughly 2, maybe sometimes a little less than 2, sometimes more than 2 jobs to complete, depending on how the timing boundaries line up. And so we would expect to see waiting printed a handful of times. And that's where, when they say when you see 6 lines of waiting and the program ends without timing out, then you're good. So 6, because it's going to print 1 immediately, and then it presumably typically needs to do 5 of these to get each of the 250s. So each 500 captures 2 of the 10 250s in the thread. So we end up with a total of 6 prints of waiting, and then the thing should end. So there's the thing. Oh, hey, nice to see you again. So what is actually failing? Now that I understand the problem, cannot assign to data in an arc. So the problem is right here, that we can't assign to jobs completed here. And that a mute problem, I think. Okay. And this is a place where I get into this in Rust and I just go, oh my. Because it's really easy to start flailing and just tacking mutes and ampersands on things and hope that you can make it work. But that's not a good way to program. So I feel like the problem is that this assignment doesn't work because there's a mutability issue. And I don't know if is it this? I don't think so. I don't think that makes anything better. Oh, no, it makes it not even compile. So no, that's not a good choice. So the problem is that the arc has a reference to, does this need to be like a mutable job status? Oh, something changed. Let me actually pull this up so we'll see more of what's going on here. Okay, so that's not even legal. So actually, I'm going to look at their hint rather than arbitrary amounts of flailing. Oh, actually, so got a suggestion here, should the status itself be mute? And I'm not sure what you mean by that. I'm not sure where I would put mute, to be honest with you. So let me actually do the hint. Oh, they do actually get into Mutex. Oh. We do need Mutex. I somehow thought we didn't. Okay. So yeah, we do need Mutex. So actually, all that business about single writer was nonsense. We do need Mutex. So we're going to need Mutex around this. New. And now a whole bunch of other things are going to have to change. Mutex doesn't exist, so we need to get that. I think that's in sync. Use standard sync Mutex. Yep. So a Mutex stands for mutual exclusion and gives us a lock on a value. And we have to request the lock in order to access the value. And while we have the lock, no one else can access that value. And so we've got some issues here. Like this now, shared jobs, status shared jobs completed is wrong because there's the mutex between the arc and the job status, and we don't refer to that anywhere here. So we're going to have to get the lock. So I think we can say let status shared be, oh, actually, let's just call it status. Oh, I'm going to just call it S for the moment because I don't want to get confused about my variables. Status shared dot lock. Nope. Oh, dot. How do we get out of the arc? Oh, we're going to have to get something. Okay, back up a hot second. Let's go find an example. I'm not convinced that the link is right, but let's. Oh yeah. Okay. So let's. So we have an arc of a mutex of just an int in this case, and so to lock. Oh, we just call lock on the counter. Oh, that's interesting. So counter is actually the arc, but we can lock the arc. So it must do some sort of automatic transforming here. So we can say lock on this. Just make sure that line compiles to make sure I'm, yeah, okay, it can. And then if we go back to here, and then we unwrap, the unwrap here is because the lock we might fail to get the lock. In particular, I think if the lock, if this object, if its status changes somewhere out in the world, it can become unobtainable. I think the problem may be if there's a thread that panicked, that had that lock and panicked, then that item can never actually be accessed because there's no way for that panicked thread to properly release the lock in a stable state. And so that's where you can get a situation where this will go boom. So the clone right off the bat, yeah. So the problem is, that part I definitely know the answer to. So we have two threads, okay? And we have the main thread, which is what's running main. So every program starts off with a thread that is running the code. And that's the only thread unless you do something to say there ought to be more threads. And then there's this other thread here that's created by spawn. So thread : spawn makes a new thread. It gets passed a closure, which is the code that thread should run. Come on, don't. So now we have two threads, one of which is going to continue running main, and the other of which is going to run the highlighted block of code. Both of those want to share access to the job status. So the job status is going to be some counter, which is how many jobs have we completed. They both want to be able to access that. That means they both need a pointer. So the job status is in heap memory somewhere, and they both need a pointer to it. And we need to make sure, and this is a particularly Rust thing, most languages would not care about this. They'd just be like, you take care of it, and I hope it works, which is why a lot of programs don't work. Rust says, okay, if we're going to have pointers, multiple pointers to something, I need to know how many there are so that I can properly free up memory when nobody else is pointing to this thing. Otherwise, that memory could be just left dangling. We have a memory leak. Or if somebody frees it too early, we might have a pointer to it that no longer works, and that would be bad. So Rust is like, I want to understand how many people have access to this. And that's what ARC does. Asynchronous reference counting keeps track of the reference count across multiple threads. That's the asynchronous part. It allows us to do the reference counting across multiple threads. And when we clone this here, we're saying, it's not that I want a new job status. We don't only want one job status. I want a new pointer to the job status that increments that reference count and keeps track of how many people are pointing at it. If we had a lot of threads, we would need to we would need to clone this many times, once for each thread that we create. I think if we go here, Yeah, so here they make a bunch of threads, like they thread spawn inside this for loop, and they clone the counter before every loop is created. So every loop gets its own pointer to that counter. It gets its own pointer to that arc. So they all can keep track of the reference counting, and Rust can know when to free that memory appropriately. So yeah, we need to clone on a per worker thread if we have more of them. That's completely correct. And that's exactly what's happening here. So we clone the arc for every thread. So every thread would have to have its own clone of that thing. And the cloning here only clones the arc. It doesn't clone. There's still only one mutex, and there's still only one job status. We just have multiple references to that mutex job status element. Okay. So here we have the lock, and S is going to be the job status now. So we will have gotten the job status out of the arc mutex business. Oh, the unwrap. Right. We need the unwrap because there is that possibility that a thread panics and the mutex becomes unusable. We'll assume that isn't happening. And we only have the two threads. Neither of them do anything very interesting, so panicking isn't very likely. But it's interesting here because Rust, by forcing us to address the unwrap question, Rust says you have to think at least a little bit about this possibility. I'm not going to let you just be completely unaware or decide to quietly ignore the problem. You have to actively say something here. And in this case, we'll probably take the easy route, which isn't a great choice, and just unwrap, but it'll work. In a better world, we'd probably want to have some sort of error handling here. And if this was in something larger, maybe the thing it's in could possibly return a result type that has an error as an option. But if this is our main, and we're not doing anything that fancy. Okay, so that should give us the status. Now if we say s dot jobs completed, I think this will fail because I think I need to dereference something. Oh, actually it compiles. Oh, interesting. So S is now the value, the job status, and we can talk to it. And so I think we could, to confirm that, we could say that's a job status. Oh, no, didn't like that. Oh, found struct mutex guard job status. Interesting. But that must then sort of convert to a job status implicitly when we do this step here because it lets this compile. Interesting. And now, just for fun, I think if we comment that out, this will compile? No. Aha. Oh, sure. It needs to be a mute S. That makes sense because we're changing the status. Aha. So it runs now. It doesn't print any waitings, but I think this thread has gone and done its thing. And so we've sort of got the compiler happy, and I think this is actually doing the right thing now. And so now we got to fix this part. So here, we're basically going to have to do the same thing that we did here. So So we're going to have to lock it, unwrap it, lock, unwrap, dot. And I think that will not really work because we never released the lock on status here, and I think that's going to cause the thread to block. So I think this will never terminate. Threading code it's a trip. Oh, I lied completely. Oh, interesting. So why? So okay, here's the issue. Let's imagine that I had said let s be status.lock.unwrap here, and then I used s.jobs completed here. Now this, I'm pretty sure, will not work because I don't think my thread can ever complete here. Yeah, I think we're spinning forever. We're not even printing. I'm going to kill that, and we'll have to restart Rustlings. The problem here is that we get the lock, and then we check on the number of jobs completed less than 10. They aren't, so we actually, why do we not print this at least once? Oh, maybe because there's buffered output. Maybe it was printing, but we never saw it because buffering prevented that from showing up. Because I'm pretty sure it probably printed at least once here. And it may have printed many, many times. I don't know. But the problem is it's never going to release the lock. There's nothing here that says give up the lock. And if we were to we can't drop S here because then because I think the kind of standard way to drop a lock is to free up a lock is to just drop the thing that got the lock. But if we drop S here, when we come back, S wouldn't exist, and that would be bad. And I don't think there's an unlock, no. So I don't think we can deal with that. And so I expected something like this to happen when I had this code here. Oops, got too much fun and excitement here. Boop. And it didn't. I was, gotta restart Rustlings watch. Oh, apologies, it's now going to go through all the stuff. And since we're getting close to the end, it's actually running a lot of tests. I think what's happening is that under the covers, this is creating some kind of local temporary variable that is holding the lock, and we use it to get the jobs completed. We compare that to 10, and then that gets dropped after the comparison is done. So the scope of this lock, instead of being more global, which is what I thought it might be, I think the scope of that lock ends up just being this expression, which is actually hugely helpful. Makes our life much, much simpler. Whoa. Iterators 2 failed. Did I go and make a change there that broke the world? Well, that's annoying. I didn't think I changed anything there. We'll have to go back and fix that so we can see this again. But I think the lock is only held for the duration of this expression. And once this expression has been evaluated, the lock is then released, which will allow us to continue. We will have to come back to this in a quick second because I got to fix this other problem, or we won't get past. What in the world happened here? Line 36. It isn't happy about value of string cannot be built from iterator item equals string. 36. Huh. So I think I was playing around. Oh, yeah, no, I remember. This happened off camera after last week. I was playing around with the iterator stuff to see if there were some other ways I could maybe do something. And I got what I thought was an interesting idea, and then there was that error, and I decided I didn't want to mess with it right then. And clearly I left it still dangling. So, oops, bad me. I didn't appreciate that was going to be a problem here. So, hey, I think this works. So we get 6 lines of waiting, 1, 2, 3, 4, 5, 6, and the program ends without timing out. Yay! And yeah, I think that I really like their Mutex thing. I think the Mutex library here is really very nice. And I understand the need for ARC and Mutex like this, but this seems, you see this kind of pattern a lot, which starts to feel kind of boilerplatey to me. And that I'm not, and I don't feel like I understand this as well as I'd like. Like the fact that this isn't really a job status, but I get to pretend it's one, is weird. So, question, do you ever have to worry about waiting for threads to shut down? Like at the end of May, the thread was still hanging with it. So you can need to worry about that. I think that in Rust, if the main thread ends, it will just take everybody else out with it. I'm not 100% sure about that, but I think that's true. It's common to want to wait for threads that you created to finish, so that you don't like wipe out a thread that's still working on something. And it turns out that spawn returns a thread join handle. So you can see we're not using that fact here, but spawn returns a join handle, and you can wait on a join handle as a way of saying, I want to like hang here until this thread finishes. So you'll frequently see code that will collect one, or if there's a bunch of threads, maybe many join handles, and then wait for all of them at the end as a way of saying, is everybody done their job? Or if you had let's say you were doing some kind of threaded sorting algorithm. So you had some kind of a vector, let's say, or actually a slice would work better for this, and you were doing a threaded quick sort or merge sort on that. And so you were going to divide that slice up into chunks, use different threads to sort the different chunks and then join them together again. You had to wait until the threads you've spawned are done before you do the joining part. And so you could capture the thread handles, the join handles, wait on those, and then go about your business when you knew what was going on after that. So, and we could actually do that here pretty easily. So we could say thread join handle is that, and it's never heard of join handle, right? Is that going to be a problem? I need let. Well, what am I doing? Let. I don't need to say join handle there. So that gives us the handle, and that so far doesn't do anything, but we could also down here say handle dot wait join, and that would be a way of saying we want to wait for that thread to finish. If that thread's already done, then this join here will instantly return and be like, that thread finished 10 minutes ago, not our problem. But if that thread's still doing something, then that would hang until the thread was completed. And I think if we put this here, now this will say, let's let the thread completely finish before we start doing any of this checking. And when the thread's completely finished, the jobs completed will equal 10. So this will not be true. We will never print waiting. And the program will end, but it won't ever print waiting because this join forced us to like let the thread do all of its work before we got there. So I think we'll get no waitings and it'll just be done. Yeah. So there are no prints of waitings here. So I'll take that out because that clearly undoes the world. And I'm going to make a note saying that we added the handle as part of a conversation about waiting for threads to complete. It's not necessary for the problem. Boom. Okay. Well, and it's unclear from an operating system standpoint if the main thread's finished, but there are still other threads running. If you leave them running, like think about if you were called a command on the command line and the main thread finished and you got your prompt back, for example, but there was still some thread running off in the wilderness, under many circumstances, not all, I mean, like if you were starting a server, that would be a reasonable thing, but in many cases, that would be not the desired goal. And there are ways that you can say, I want to leave a thread running. I don't know what those look like in Rust. I've seen that in some other languages, but I don't know what that looks like here. So it's possible, but you wouldn't want that to be the default, probably. Okay. So other questions? Good questions. Lots of good ideas here. Any other questions about this? Comments? Boom, bop, bitty. So now that's the only threads exercise. So now we're off into macros. And as I said at the beginning, macros in Rust are something I have done basically nothing with. I've read a little bit, but man, not much. I have a little experience with macros in Clojure, but not a ton there either. I mean, macros are really not a space I've done a ton with. So I may be a little flaily here. We may have to look some things up. Okay, so this doesn't compile because my macro is not found in scope. Is this just an exclamation mark issue? I know that in Rust, oh, that's all it was. Okay. So when you define a macro, apparently it puts the exclamation mark there for you. Didn't understand that. I knew that things like print line bang and the other sort of things with bangs were macros, but I didn't know that that was actually an enforced feature of the language. So that's cool. Learned something new there. So the main thing about macros is that they apply to the text of the program before it's actually compiled. So we're actually manipulating the text of the code before the compiler actually does the compilation process. So here we're saying that my macro takes no arguments and it converts to be this block of text. So my macro open close with the exclamation mark, because that apparently gets just stuck there, gets converted to this block of code before the compiler gets to it. Oh, yeah, so that's a good point. In the chat, there's the comment that it's the tokens, not the text. And that's actually a useful distinction. So by saying the text, I make it sound like it would be at the level of the characters. And it's not at that low level. So the parser has had a go at it. And what you're getting is a parsed sequence of tokens. And I assume that the subsequent exercises will get us into actually looking at the tokens. Here, we don't take any arguments. We don't actually, there's no code here that we do anything with. We're literally just replacing this with this. So it doesn't come up here, but it could, I presume, come up in some of the other exercises. So that's an excellent point. Thank you for sharing that. So I'm being careful about my language. So in this case, this is just being replaced by this block, and there aren't any arguments, and so nothing interesting happens. So that succeeds, and that part's simple. So that one was easy. I'm guessing it'll get weirder and more complicated. Questions? Okay. Now, macro 2, make me compile. How is this? Oh, here the rules come before main, and here the macro rules are after main. Is that really the problem? Yeah, I bet it is. So presumably, you have to define the macro before you can use it. Okay, well, that's interesting. I didn't know that either. So I've learned that it puts the exclamation mark on for you, and you don't have a choice in the matter, and that you have to define the macro before you use it. That actually makes some sense because we're not talking functions that where we can like have a pointer to the function in memory and call the function at runtime regardless of when it got defined. Here, the macro has to exist before we use it, so we know exactly which macro we're talking about. And the macro then compiles out. There will be no, there'll be nothing in the code, especially in production code. There'll be nothing to actually reflect the existence of my macro anymore, I suspect. That the code will literally just be this block, and there won't be anything that would sort of show that my macro had ever been there. And so it's got to be able to compile out all that stuff. And yeah, so the comment about, you know, I was thinking about C, where C is purely literally text. So macros in C, which are just awful on many levels, but they are literally textual substitution. There's no parsing. Well, that's not entirely true. There's a little tokenization, but there's not much. And so that's totally different. Closure macros are more token oriented. So closure macros would be more like this in some ways, but still in other ways, like completely different. So yeah, it's not going to be the same at all. Okay, so that was easy. I'm pretty sure that it will get harder. And it's interesting that you like Rust macros. Again, I haven't done much of anything with them. I have a project that I want to actually write in Rust. And one of the it's to rewrite something that currently exists in Clojure and relies pretty heavily on the dynamic, untyped nature of Clojure. And there are some performance issues with it. And one of the reasons I want to implement it in Rust is to see how that impacts both runtime, but also memory usage. Memory usage in the Clojure version is pretty aggressive. It chews up a lot of memory, and I think a lot more than strictly necessary. Yeah, Clojure the language, which is a language I have a lot of experience with compared to Rust. And so I really would like to take this Clojure code or this project and write it in Rust and see what that looks like. But one of the places where I'm spending a lot of time thinking, to say I'm stuck would imply that I've started, and I haven't started. So it's not really that I'm stuck, but I certainly thought about it a lot. There's going to be a lot of questions about how to handle the dynamic typing in the system. And one thing I'm wondering about is whether macros would be the right tool for the job. And I don't know. And I don't want to get bogged down in that here, but if there's some, like after we finish this, maybe next week, I might describe, after we finish Rustlings, which I'm thinking, given the time, definitely not today, maybe Tuesday, I don't know. But after I finish the Rustlings, I might take a little time, if there's an appropriate amount, to describe the project in more detail and see what kinds of thoughts people have. Could be, I think dynamic, literally the dynamic, that type may also turn out to be important. I think actually dynamic dispatch might be the easy way. But like I said, if I'm doing this in Rust, I'm kind of thinking that part of the reason to do it in Rust is performance. And so dynamic dispatch sort of eats into that a little bit. So I don't know. Maybe I'll write up a description of what the thing does on my blog, and I'll post a link to that next week and put it on Twitter. But let's not get too lost in that right now. That's a problem for another day. So we're on macros 3, and feedback and ideas from people, absolutely appreciated. There's people here with way more Rust experience than me. So, there's almost certainly more than one way to do this, and hearing about different options would be nice. Okay, so we have a module macros, which defines our macro, and then we try to call it. And that isn't there. And that's presumably, here I'm guessing this help is the thing. So we probably need some kind of macro use thing. Maybe? I don't know, actually. Or is this something where I just say macros? No, that was not a good idea. Cannot find macros. So I suspect the name spacing is different for macros, and this is not doing the right thing. Let's look at it. There we go. In order to use a macro outside of its mod file, you have to do something special to the module to lift the macro out of its parent. Well, that wasn't helpful. So it seems like this macro use has got to be the thing somewhere. Let's Rust macro use. Macros by example. scoping. That would seem to be potentially relevant. Mod uses macro. Macro use. Mod. Make a module's macro scope not end when the module is closed. Aha. That would probably work, I'm guessing. Aha, it did. Now, I feel like that's probably not the answer they were looking for, though, because that basically bleeds everything in that module out into the containing module, when I'm guessing that the intent was more to do something more controlled than that. Well, Lumical, if you've written a project in Rust, you're ahead of me probably, because I'm not sure. I could say I've written several half projects or be really little things. I do have an actual project or three that I want to write in Rust this year as part of what we're doing here, but yeah, it's not something I've done anything serious with. So yeah, I feel like that's not the best answer. So I don't know, textual scope. So we define M, we can call M. Mod uses macro. M bang. Oh, so this thing? Oh, that's because there's, no. Huh. I'm not sure. Oh, cool. That's a neat program. RNA or DNA nucleotides and translating them into amino acid chains. That's nifty. Huh. Well, okay. I think I don't want to get too bogged down in this. I think we'll let this go. I'm not. I do feel like there's sort of a better way to do this, but I'm going to let this be for now, because watching me read the internet is not super exciting. So, oh, this is the last one. So we're really not going to do anything super exciting with macros here. This is the last one. I was expecting maybe we'd have more stuff, but okay. So here we're looking at pattern matching in macros. I think there's a suggestion. Yeah, I kind of don't think that's going to work, because I think the use actually doesn't apply to macros in the same way. Find out. Yeah. Oh no, that's because that's just me and semicolons. Yeah. Yeah. So I think that a use like this only applies to functions, and I think macros are handled differently. So I don't think that works. But Oh, yeah, right. It would help if I actually had syntax that made some sense. Okay, it still doesn't work, but yeah, I don't think this is doing the right thing. I think that uses at some level are about functions and not about macros, because I think, yeah, this is a place where I'm not super knowledgeable, so I don't want to say too much and risk lying. That would be bad. And now, oh, I forget what I had there. Well, the compiler will tell me. Macro use. Macro use. Okay, and then there's a comment. Stack Overflow suggests pub crate use my macro at the end of the mod block. Oh. Oh, now that sounds promising and more like I think we were thinking of. So pub crate use my macro, and then here macros : : so that this is maybe sort of saying it can be exported. Oh, it didn't want the exclamation mark, I think, there. No my macro. Oh, because I can't spell mac. No, that was macro. My macro. Oh. Let's actually Google that. Rust, boom, macro. This could well be the pub crate use name of macro. But that's not, it is what we're doing, but it's not working, right? And I bet that's the link that I found, right? Oh no, actually it's a different one, maybe, or not. Oh, the attribute should be on every module and parent module until you get there. So you kind of have to leak it out through the entire hierarchy. Wow, that seems like a lot. Come on, copy you. Is this the same Stack Overflow? We're looking at the same thing. Yeah, we are. So why? Because this seems like that would be a thing. Pub crate use bar, and I've got pub crate use my macro, and that looks the same. Huh. What is it yelling about? No my macro in the root. Oh, no. That's defined right there. Computers, so annoying. Macro rules, we're using macro rules. So we're not using a different approach to macros. Because there are different ways of making macros in Rust that I don't fully grasp the distinctions between them. But I wanted to make sure that wasn't the thing. And somebody suggested just the ordering maybe mattered. I feel like it would make more sense to define it and then say something about it, but worth a shot. Yeah, no, that did not make things better. And now there's Import resolution is stuck. Try simplifying macro imports. Macros, colon, my macro. Oh, I am not sure why that's not working. And we could look up macro export, Rust, macro export. Let's see what that does. Macro export. That finds that because we said to export it. Well, we could try that. Let's comment that out. I'm going to leave it there though, because oops, let me go back in front of that. I probably don't want the macros in front. Yeah. Well, no, hey, that worked. So, I mean, it's still not, oh, what version of Rust do I have? That's a great question. A recent one. Rust C minus version, minus version, probably. 159. What version do you have? Now, it's, I guess, dimly possible that Rustlings is using a different version, but I don't think it is. I think that's what so rust up list? Is that how you do that? Show, rust up show. So I have the stable 1.59. Yeah, and certainly it's not nightly, but it's well past the 132. So I'm a little confused about why that doesn't work. But I don't think we want to try to spend forever debugging that. That probably is not the best use of everybody's time. This did work, so thank you for the macro export suggestion. I still kind of like the idea of being able to do something like this so that you have namespaced macros, like being able to say macros : my macro would be nice. So I may explore this outside of the video chat, and if I figure something out, I'll mention it next week. Or I'm not sure what the best. Being new to streaming, I'm not sure what the best way to do things like that is. Whether I should like post things like that on a blog, or just mention them on Twitter, mention in the next stream, but not everybody can attend every stream. And so I don't know. I'm not sure. If you've got suggestions on that, absolutely feel free to share. That would be awesome. Okay. So I think we'll move on back to macro 4. And I'll see if I can make some sense out of what's going on there later. So here, and this is the last macros thing, we get a little bit of pattern matching, and this gets to the tokens comment from way back by Wagatha quite a while ago. So here, it will pattern match against either no arguments or, in this case, one argument. And so the my macro with no arguments is going to pattern match here, and we'll print check out my macro. This isn't going to match that pattern because it has an argument, and so it's going to match this pattern where we have a variable of a type. And the expert type here is, this gets into the tokenization. So you can set, there's some types that you can specify in macros that indicate, are you looking at a single number, variable, an expression? I actually have dug into that a lot. So I don't know what exactly the options are, but there are a handful of types that allow you to talk about different aspects of Rust syntax. And that, again, implies that the parser, at least the lexer, has had a bit of a go at the thing. And you're not looking at just raw characters. And so this fails. Why does this fail? No rules expected this token in macro call. Don't know what's going on there. Let's look at the hint and see if the hint tells us something useful. The way macros are is want to see something between each macro arm so it can separate them. What? You need only add a single character to make this compile. Is this like a semicolon thing? Or a comma? Maybe? Comma? Nope. Can't do that. Semicolon. Oh, there we go. Okay, that was weird. Okay, so it just needed a statement terminator, separator, I guess in Rust, to say that this was separate from that. And without that semicolon, it wasn't able to separate those two things. And so this is going to be our name for whatever we match. So in this case, it'll be the 7777. And it has type expr. It is an expression. And it works. And I think because it's a type expr, we could do things like 2 plus 3. Well, it helps if I can type. And that will also work. Yeah. So it's putting this whole expression 2 plus 3 in for val. So it's not evaluating 2 plus 3. That piece of syntax is being copied to here, and then the compiler probably sees it and says, oh, that's all constants, and collapses it to 5 as part of the compilation optimization process. But if that called some interesting function, then we would get the function call and all of that fun stuff. So cool. So I feel like that was pretty simple stuff about macros and left me with a lot of unanswered questions. I'm gonna have to learn more about macros, clearly. Well, I don't know. I probably should learn more about macros. Whether I need to will kind of depend on the projects that I'm doing, whether macros are the right tool for the job. In most circumstances, if you can avoid using macro, that's often preferable because you'll get better error messages and debugging assistance and things if you don't use macros. So like when you need them, they're awesome, but if you don't need them, probably best avoid them. So we'll see. Let's see, what is 11:39? We can get through a little more here. And thank you for all the suggestions. There's a lot for me to clearly dig through there. I will have to explore. Oh, quiz 4. We get a quiz. Let me guess. This will be just a few random things about macros. Oh, they actually do cover modules and macros. That's interesting, which is good. Write a macro that passes the quiz. No hints this time. You can do it. So literally all we have is the test. So we want to define a macro, my macro, and because I'm a doofus and I was moving quickly, I don't actually remember the syntax very well. So let's just grab a simple example of the macro, and then we can use that as a starting point. So macro rules, my macro, and they're calling it my macro again. Okay. And my macro takes a value. So we had $val : expr, and we're going to print and we want to insert something. So really, I want a format here, I think. Format, hello, do, exclamation mark, $val, and I think I've got a string issue somewhere. Ooh, wow, all kinds of noise. Oh, printline does this. I don't need the format business. Ah, yeah. Thank you, Patathos. You're completely correct. And now we're still not happy. And that's because, oh, that's a semicolon problem. No, it's not a semicolon problem. It is, well, mismatch. So let's see. Back to the top. Unused import super. Oh, presumably that's trailing semicolon and macro used in expression position. So I bet I don't want that semicolon. Okay. Oh. There is a CFG test right there. Mismatch types. Expected, nothing, found, stir. Oh, I'm printing here, and I don't want to print. So actually, I did want format back at the beginning. This isn't supposed to print a string. It's supposed to generate a string. Hey, now my test failed. That's because I've got too many exclamation marks. Oh, that's because they included exclamation marks in their arguments. So I've got an exclamation mark in val and one in my string. And now it will work. Yay! Yeah, that was dumb. Format, not print. So yes, all the suggestions were excellent. You were right on. And there's a suggestion here for a quiz that might be worth looking at, or an exercise that might be worth looking at for macros. Oh, no, I copied the wrong thing, clearly. Oh, come on, copy. There we go. Oh, I don't know this Rust quiz. Well, that's interesting. I'll have to look at that. Let's not go there right now, but this is new to me, so I will have to look into that. So thank you for the suggestion. Good idea. So, okay. So we've passed the quiz. Go us. man, that was, yeah, a lot of flailing. So I can say we're done with that. And then it's quarter till, so we can do a little more. Pass the quiz, and now we're into Clippy. Now, actually, I honestly don't know anything about Clippy. I think Clippy is like a linting kind of thing. I don't really know. The Clippy tool is a collection of lints. Oh, yeah, to analyze your code so you can catch common mistakes and improve your Rust code. For these exercises, the code will fail to compile when there are Clippy warnings. Check Clippy suggestions from the output to solve the exercise. Okay. Oh, interesting. Rust quiz can be really hard. Well, that might be. I mean, I guess it's part of it is like how much Rust do I really want to learn? But I think I actually really want to get a. I don't know that I want to like be expert, whatever that would mean. But I think I would at least intermediate is probably where I need to be to answer some of the questions that I want to answer. And so, if Rust, I might try Rust quiz out and see how it works for me, and maybe that even becomes part of the stream. I don't know, but I certainly appreciate the suggestion, and we'll have a look. Okay. So Clippy is grumpy because an approximate value of pi is found, and they're like, oh, wow. So that's pretty crazy. So the compiler, so coming back to the comment, is it obvious which ones are the really hard ones, or is really hard a function of like, I got stuck and I don't know what to do about it yet? I'd be curious to know like if they're labeled in terms of difficulty in some ways. But it sounds like it'd be worth experimenting with. So coming back to this is really interesting because that suggests that Clippy is doing some not trivial searching for things that look like pi and telling you that pi already exists. And I don't know whether it's the value has got to be close to pi, or somehow if the name here matters. I guess we could find out if I call this frog. Rename symbol, frog. Whoa, that didn't do a thing. Why did that not do a thing? Rename symbol, frog, enter. Huh, I don't know why. Whatever, it's not that complicated because there's only two occurrences. Frog. There's Clippy still fuss. And Clippy presumably is focusing more on the value than the name, which would make sense because you could imagine people calling it various things. And so it's telling us that we should use F32 const pi instead. And yay, and Clippy is happy. Well, that's cool. I didn't know that. That's nifty. And I assume there must be ways to turn Clippy on and off when you compile your code. I guess I want to check that. Rust turning on Clippy. Rust run Clippy. Okay. So Clippy is opt-in. Oh, so you add it as a component, and then you say cargo Clippy, and it'll run Clippy for you. Okay. That's cool. I'm actually a big fan of things like this, especially when I or my students are first learning something. Like the more feedback you can get from things, the better. yeah, I like being told kind of what the right or what the standard in the community is. And once you get good at it, right, then you can choose to ignore those rules. But when you're first learning, I think that having those rules pointed out to you is really useful. So I'm definitely a fan. Clippy 2. So let's see. Loop over option, which is an option that's more readably written as an if let. Oh, that's interesting. That's sort of weird to loop over an option like this. Yeah, I totally would agree that if let would be. So if let sum x equal option, so then we'll pattern match this against the value of option. We should get 12 for x, and then we should be able to do the happy thing. And that worked. So that's not very complicated. So I haven't done anything super fancy here. Oh, wow. An internal compiler error when you ran Clippy on your library. That doesn't sound fun. So is that, so presumably Clippy failed somewhere, that the parsing tools in Clippy died somewhere on your library. Well, that doesn't sound like a fun thing at all. So I think that takes care of that. And that is both of the Clippy exercises. And now we go to conversions, which I think is the last set of exercises. Let me actually confirm that. Rustlings list. Yeah, so there's conversions and advanced errors. Well, the compiler unexpectedly panicked. This is a bug. We would appreciate a bug report. I'm sure they would, because they're not expecting that. It's 11:53. Technically, this ends in 7 minutes. I have another meeting at 12 and another meeting at 1. You'd think on a Saturday I wouldn't have all these meetings, but that's my life. So I think actually rather than start the next thing, I'll probably wrap this up here. And then that'll leave us with just a little bit to do next time on Tuesday. And I'll have to figure out what's going to happen with the other half of Tuesday. Whether I start actually working on a project or use that to try to explain the dynamic system that I was talking about. I'll wrestle with that. So the question, can a crate provide their own rules? Seems like that could be handy as a library author. Yeah, I'm not sure I know what you mean by rules. Is this in the context of Clippy? Like that there could be best practices for your library and you'd like Clippy to check those? Yeah, if I wanted to warn about some foot gun. Yeah, I don't know the answer to the question. This is way past my pay grade. If somebody else here knows the answer to that question, feel free to share. I don't know. Well, I guess we can ask the internet. Can I add a rule to Clippy Rust? Adding lints. Oh, well, that goes someplace bad. Rules. Don't go away. I do not want you to like talk to me. Yeah. The quick skim looks like the answer is no. You probably can't add rules. It looks like you can control what rules are being applied, but adding new rules, which doesn't super surprise me because the as it said in that discussion, you'd have to have access to some pretty low-level compiler components potentially, and how you would write those could be complicated. You could imagine maybe having a macro of some, and maybe you could do this yourself. You could have, I don't know, maybe not. Maybe the thing to do is design the library that does, so it doesn't have ways to shoot yourself in the foot. Maybe that's the recommended approach. Don't know. Okay, well, I'm going to stop there. You are awesome people. Thank you very much again for the feedback and the suggestions. And I will try to figure out why that one macro thing didn't work. And if I do figure that out, I'll share that back in some fashion. And I'll be here Tuesday, 10 to noon, my time, so same time. And we'll finish the Rustlings up and figure out where we go from there. I'll have to do a little thinking and planning. Rustlings was nice as a way to get started because I didn't have to do much thinking. I just did the next exercise. But now I'll actually have to like have a plan and do some real programming. So thank you all for your help and assistance. I don't think I have any other announcements. Be safe, and I will see you next time. Thanks a lot. Ciao.